Hello, welcome to the second part of your lessons this week. Very much continues from the last. Today we're going to look at evidence of evolution, and we'll start with our 6-mark questions. First one of which, following on from last lesson, is why are advantageous mutations more likely to get passed on? 2, how many chromosomes do gametes have? 3, which organ produces insulin? 4, state the equation for gravitational potential energy. 5, what type of atoms form ionic bonds? And 6, describe why blood flow needs to increase during exercise. Okay, so running through those answers nice and quickly then. Advantageous mutations are more likely to get passed on for the simple reason that a species that has an advantage is more likely to breed and so is more likely to be able to pass on its genetics. Gametes have 23 chromosomes. The pancreas produces insulin. Gravitational potential energy is the mass of the object times by the height of that object times by the field strength of the planet that it is on. On Earth that'll always be 10. Ionic bonds form between a metal and a non-metal atom, and then blood flow needs to increase during exercise because respiration is taking place. Exercise means we require more energy, which means we need to respire more, and respiration to take place needs oxygen and glucose, both of which are transported through the blood. So more blood flow means more of those ingredients, so more respiration can take place, so you can continue to exercise. Okay, so last lesson we looked at the process of evolution, and today we need to look at the evidence for that process and exactly how we know that evolution takes place. And hopefully you're all aware of Charles Darwin, who is credited with discovering evolution, and he wrote a very important book about it called The Origin of Species, in which he outlined the theory of evolution, which was hugely controversial at the time because the main thoughts, the main ideas of how we all got here and to look like we did was because God made us that way and made us in his image. So it was incredibly controversial, and it was really damaging to his reputation to put forward this theory, but now it's pretty universally accepted and we've got lots more evidence to back him up. And we're going to look at 3 key bits of evidence for evolution today. We're going to look at variation in species, which is pretty much what we talked about last lesson. We're going to look at fossils, and then we're going to revisit something that we've already looked at, which is antibacterial resistance. Okay, so we'll start with variation in a species, and then we'll go on to look at the other ones. It was when visiting the Galapagos Islands that Darwin first formulated his theory of evolution. And what it was that he found on the Galapagos Islands that led to this theory was the mass amount of variation in species within the island, particularly in the finch population. These birds were all clearly very closely related. They had lots of features the same, and yet they had variations. And these variations, such as colour and beak and behaviour, allowed them to be better adapted to the food and the environment of the island. And this told him that there must be a process working here. There must be something that allows these species to, over time, become more adapted to their surroundings. And he went on to find many more examples of this. But it's his finches, or his work around these finches, that are really credited with the first seeds of evolution, so much so that they're included on the back of the old £10 note alongside a picture of Charles Darwin himself. So now let's think about fossils, and let's begin with exactly how it is that fossils form. Ordinarily, when an animal dies, it will simply undergo decomposition and decay, and there'll be no evidence that it ever existed. But if an animal dies in the right circumstance, like it falls to the bed of the ocean and rocks and sediment forms above it, it will undergo a process by which a fossil forms. That decomposition will occur, but then those hard parts of the body, like the bones and the shell, will undergo great amounts of pressure, and that will mean that a version of that organism is preserved as a rock or as a fossil. And it's looking at these fossil records that allow us to see how organisms have changed over the time, which is a form of evidence of evolution. So discovering fossil records allows us to go back and form a fossil record, and this shows us how different organisms on Earth has changed over the time. The deeper in the earth they are, the older that organism must be. And it's worth remembering that us humans are relatively recent on Earth, and fossil records show that some form of life like bacteria has existed on Earth for billions and billions of years. And looking at these fossils and looking at how they've changed over the years lets us see exactly how evolution took place, how it is that animals have been able to change and vary across these billions of years, how a small change between two species shows that they must be related, or indeed how variations have taken place over generations, showing an adaptation and improvement of a species. How, for example, monkeys lost their tails as they evolved into Homo sapiens that we are. That fossil record shows that gradual change, and it will show all the variations that exist within those millions of years that evolution has taken place in, show that gradual incremental improvement as genetic mutations came about and were accepted or rejected. However, fossil records are limited. We don't have absolutely all of them. We're missing some species, some versions, either because these have been destroyed during mining and that kind of thing, or they just never formed in the first place. We need specific conditions for them to form. However, by continuing to look, we will find more and more fossils, which will give us a greater idea of how evolution took place and give us a greater fossil record, giving us better evidence. Okay, so finally then, that last piece of evidence is antibacterial resistance. And we've looked at this in lots of detail. You all answered the questions really well on it, so we'll just recap it very quickly. And this is that process where bacteria very rapidly is able to become resistant to antibiotics. And it does that because some are naturally resistant, and if you fail to take the full course, that resistance builds into the bacteria until they all become resistant to the antibiotics. This is evolution in action. Because bacteria reproduces so quickly, because it reproduces asexually, we're literally able to see bacteria becoming resistant almost in real time. And that means we can see that evolution takes place. There's no thought behind it. It's just this natural process of the fittest, the best bacteria surviving and being able to pass on their DNA. So that work we did on antibacterial resistance is really useful for the unit on health and disease and medicines, but it's also useful here when talking about evolution. It's evidence of that. Good. That's pretty much all we need to look at this lesson. We won't finish on an exam question. Those of you that want to do an extra exam question, there's one in the extension task this week. These lessons will continue on here while I'm still in school doing face-to-face lessons for the rest of you. So hopefully you're all able to sort of do a little bit of a blend between in-class work, catching up with things on here, and as I say, they'll continue all the way through. Thanks very much.